Welcome to the Learning Academy. Today we'll be looking at the planet Mars. A weird green glow has been spotted on the atmosphere of Mars. It is the first time that this emission has been seen on a world beyond Earth. The atmosphere of Mars has a distinct green glow, just like planet Earth's. The European Space Agency's Trace Gas Orbiter, TGO, spotted an emerald glow in Mars' wispy atmosphere, marking the first time the phenomenon has been spotted on a world beyond Earth's. One of the brightest emissions seen on Earth stems from night glow. More specifically, from oxygen atoms emitting a particular wavelength of light that has never been seen around another planet. However, this emission has been predicted to exist on Mars for around 40 years, and TGO has finally found it. The green emission is characteristic of oxygen. Sky watchers at high altitudes here on Earth can see this signature in the ethereal, multicolored displays known as the auroras, which are generated by charged particles from the sun slamming into molecules high up in the atmosphere. But night glow is different. Night glow is caused by the interaction of sunlight with atoms and molecules in the air, which generates a subtle but continuous light. This emission is hard to see, even here on Earth. Observers often need an edge-on perspective to make it out, which is why some of the best images of our planet's green night glow comes courtesy of astronauts aboard the International Space Station. Day glow, which is the diurnal component of this constant emission, is even harder to spot, and it's driven by a slightly different mechanism. While night glow occurs as broken apart molecules recombine, whereas day glow arises when the sun's light directly excites atoms and molecules such as nitrogen and oxygen. Researchers used TGO's nadir and occultation for Mars Discovery (NOMAD) instrument suite, which includes the ultraviolet and visible spectrometer UVIS, to study the red planet's air in a special observing mode from April through December of 2019. Previous observations did not capture any kind of green glow on Mars, so it was decided that they would reorient the UVIS nadir channel to point at the edge of Mars, similar to the perspective that is seen in images of Earth taken from the ISS. The team of researchers scanned the Martian atmosphere at altitudes between 12 miles and 250 miles. They found the green oxygen glow at all heights, though it was strongest around 50 miles up and varied with the red planet's distance from the sun. The researchers who worked on this project performed modeling work to better understand what's driving the glow. Those calculations suggested that the light is driven mainly by the breakup of carbon dioxide, which makes up 95% of Mars' very thin atmosphere. And this carbon dioxide is broken into carbon monoxide and oxygen. TGO noticed these stripped oxygen atoms glowing in both visible and ultraviolet light, with the visible emission about 16.5 times more intense than the ultraviolet light. The observations at Mars agree with previous theoretical models, but not with the actual glowing that we've detected around our Earth, where the visible emission is far weaker. This finding suggests that there is more to learn about how oxygen atoms behave, which is largely important for our understanding of atomic and quantum physics. TGO has been circling Mars since October 2016. The orbiter is part of the two-phase European-Russian ExoMars program, which plans to launch a live hunting rover called Rosalind Franklin toward the Red Planet in 2022. The Rosalind Franklin was originally supposed to lift off this summer, but technical issues with the spacecraft's parachute and other systems caused the mission to miss that time frame. The new TGO results, which were published, will be helpful to the Rosalind Franklin team. This type of remote sensing observation, coupled with in situ measurements at higher altitudes, helps us to understand and predict how the Martian atmosphere will respond to seasonal changes and variations in solar activity. Predicting changes in atmospheric density is very important for forthcoming Mars missions, inclusive of the ExoMars 2022 mission that will send a rover and a surface science platform to explore the surface of the Red Planet. Mars is a planet that exhibits climate change on a large scale. Although the Martian atmosphere used to be thick enough for water to run on the surface, today water is either scarce or non-existent. The atmosphere on Mars is also too thin to easily support life as we know it on Earth, although life may have existed on the planet in the ancient past. The climate of Mars comes from a variety of factors, including its ice caps or polar caps, water vapor, and dust storms. At times, on Mars, there are giant dust storms that blanket the entire planet and last for months, which turns the sky hazy and red. The atmosphere of Mars is about 100 times thinner than Earth's, and it is 95% carbon dioxide. According to NASA, what is present in the atmosphere includes 95.32% carbon dioxide, 2.7% nitrogen, 1.6% argon, 0.13% oxygen, and 0.08% carbon monoxide. There are also minor amounts of water, nitrogen, oxide, neon, hydrogen deuterium oxide, krypton, and xenon in the atmosphere of Mars. Early in its history, particularly in periods older than 3 billion years, Mars had a thick enough atmosphere for water to run on the surface. We have noticed this through orbital pictures, and we have seen vast river plains and possibly ocean boundaries, while several Mars rovers have found evidence of water-soaked rocks on the surface, and these include hematite and clay. However, for reasons that are still poorly understood, the Martian atmosphere thinned out. The leading theory is that Mars' light gravity, coupled with its lack of global magnetic field, left the atmosphere vulnerable to pressure from the solar wind, the constant stream of particles coming from the sun. Over millions of years, the sun's pressure stripped the lighter molecules from the atmosphere, thinning it out. Processes being inspected and investigated by NASA's MAVEN, Mars Atmosphere and Volatile Evolution mission. Other researchers hypothesize that perhaps a giant impact by a small body would have stripped the atmosphere away. The thin Martian atmosphere and its greater distance from the Sun means that Mars is much colder than Earth. The average temperature is about minus 80 degrees Fahrenheit, although it can vary from minus 195 degrees Fahrenheit near the poles during the winter to as much as a comfortable 70 degrees Fahrenheit at midday near the equator. The atmosphere of Mars is also roughly 100 times thinner than Earth's, but it is still thick enough to support weather, clouds, and winds. There is also radiation at its surface, but it shouldn't be enough to stop Mars exploration. Analysis by the Curiosity rover found that a single mission to Mars is comparable to the radiation guidelines for astronauts for the European Space Agency, although it does exceed those of NASA. Giant dust devils routinely kick up the oxidized iron dust that covers the Martian surface. Dust is also a permanent part of the atmosphere, with higher amounts of it in the northern fall and winter, and lower amounts in the northern spring and summer. The dust storms of Mars are the largest in the solar system, and are capable of blanketing the entire planet and lasting for months. These usually take place in the spring or summer. Researchers have theorized as to why dust storms can grow so big on Mars. They say that it starts with the airborne dust particles absorbing sunlight, which warms the Martian atmosphere in their vicinity. Warm pockets of air flow toward colder regions, generating winds. Strong winds lift more dust off the ground, which in turn eats the atmosphere, raising more wind and kicking up more dust. A study in 2015 further suggested that the momentum of Mars, which is affected by other planets, generates planet-circling dust storms when that momentum is at its greatest during the early part of the dust storm season. At times, it is even snowing on Mars. The Martian snowflakes, made of carbon dioxide rather than water, are thought to be very small particles that create a fog effect rather than appearing as falling snow. The north and south polar regions of Mars are capped by ice. Much of it is made from carbon dioxide and not water. According to NASA, seasonal changes are due to the waxing and waning of the carbon dioxide ice caps on Mars, as well as dust moving around in the atmosphere, and water vapor moving between the surface and the atmosphere. Most of the water comes from the North Water Ice Cap, which is exposed and sublimates during the Martian summer when carbon dioxide evaporates off the cap. During winter, the temperatures in the polar regions are cold enough for the CO2 in the atmosphere to condense into ice on the surface. The carbon dioxide then sublimates off the ice cap in the spring and summer, returning to the atmosphere. In the northern hemisphere, the carbon dioxide ice cap completely vanishes in the summer, uncovering a large perennial water ice cap. During the southern hemisphere summer, a small carbon dioxide covered ice cap survives. This perennial ice cap is offset from the South Pole. This cycling of the CO2 into and out of ice on the surface changes the atmospheric pressure, the atmospheric mass, by tens of percent over the course of a Martian year. Several missions have been planned to monitor the long-term climate changes on Mars. ExoMars Trace Gas Orbiter, MAVEN, Mars Express, Mars Odyssey, Mars Orbiter Mission, and Mars Reconnaissance Orbiter. Current surface missions include NASA's Curiosity and Opportunity rovers. Other surface missions are planned for the coming years, including NASA's Mars 2020 and an ExoMars rover from the ESA. Mars could have once harbored life. Some think that life might still exist there today. A number of researchers have even speculated that life on Earth might have seeded Mars, or that life on Mars seeded Earth. Viking landers famously sought life on Mars during the late 1970s, but came up empty. Today, some of those results remain controversial. One in which a sample of soil was heated and then checked for organics. While Viking did not find any organics, other researchers have alternate explanations for its failures due to the instruments not being sensitive enough to detect life. Oceans may have covered the surface of Mars in the past, which would have provided an environment for life to develop. Although the red planet is a cold desert today, researchers suggest that liquid water may be present underground, providing a potential refuge for any life that might still exist there. Several studies have shown that there is an abundant water ice beneath the surface. A feature called recurring slope lineae sometimes occur on Martian slopes. In 2015, researchers announced that hydrated salts have been found inside some of these features, which suggests that RSLS have a sort of briny water in them, an environment that could be hospitable to some forms of extreme life. However, more studies in 2016 and 2017 shed some doubt on that theory. One study suggested that the water may arise from the Martian atmosphere, while others maintain that the RSLs are instead due to dry sand. NASA's Curiosity rover is currently seeking habitable environments during its mission on Mars, which began in 2012. NASA's Mars 2020 rover is expected to take that up a notch, which will include catching potential samples with biosignatures for future missions to retrieve. The ESA also plans its own biosignature hunting rover as a part of the ExoMars mission. The challenge is that these rovers, although powerful, cannot carry the same type of sophisticated laboratory equipment usually used on Earth to find signs of life in old samples of rocks. Although it is difficult, even for Earth samples to pass the life test, a geological signature can mask a life. Discoveries of ancient life in Greenland and Quebec in Canada in 2016 and 2017, for example, still remain controversial. This has been a deep exploration of the planet Mars. We've looked at the glow that is currently around the planet, and we've also looked in depth at the atmosphere. Like, comment, share, and subscribe. Leave your comments down below. We crave your comments. Let us know what other things you'd like for us to discuss in regards to Martian planet or any other planet in our solar system or our universe. Thanks for watching.